So I'd like to introduce ourselves. My name is Rod Batchelor.
I'm Vinay Reddy. We both are product managers from NSBU.
And we're going to talk to you about service insertion. So service insertion means a lot of things to different people. We're going to focus primarily on security service insertion, but to begin with, I want to do a little bit of level setting here and get an understanding of kind of where you guys are coming from. So first of all, easy question. How many of you have heard of NSX? Okay, most people, that's good. How many of you have tried NSX? Wow, excellent. How many of you are using NSX? Even more, right? How many of you have done any service insertion? Oh, excellent. Okay, now we got to break it up between us.
Yeah.
How many of you are using it for endpoint? Okay, see, very and for network service insertion? Okay, oh, Vinay wins. So we're going to talk about it. So for some of you, this is going to be review. Maybe you learn a few things about what's new. For others, going to get some information here and find out why some of the additional value prop that we have from NSX. I'm also going to do a little level setting, talk about NSX a little bit. There were a few people who haven't, still a few people that haven't heard about it so much. So I'm going to do a very quick overview there. But first, because we're product managers and we can't help it, we do sometimes talk about things that haven't shipped, even if we're not supposed to. So we won't say any dates, and as a matter of fact, we can't even promise that anything we say will happen unless it's already available as a product. So if you make any buying decisions based on what we say, that's not shipping, then it's not our fault. If you make buying decisions based on what we do say, excellent. Yep. I'm going to buy you a beer afterwards. So when we want to talk about NSX here, one thing that's really important, and this is a central tenet to NSX, is we're all about the app. It's called network. It's basically networking and security and so on, but really it's networking and security around the app. It's not let's build a network, let's secure it, and then let's throw some apps in it. We've got some apps, let's secure these apps and get them out and deployed. So, security of the apps and data. Number one thing that we're worried about here. The second is something I think you're all familiar with, you're all exposed to it all the time, and that is the speed of delivery, right? If we're talking about situations, let's talk especially in firewall rules. Let's zero in on those guys right now. So we've all gotten to the point where we can deploy apps really quickly. We've got our automation set up. We can get it out. We can get it spun up. We can get things plumbed and so on. But we're going to need some firewall rules for this new short-term marketing app that we want to do. Firewall guys come back and they say, it's going to take 6 or 8 weeks. I'm going to have to take a look at this. Anybody ever experienced that? Like, yeah, a few of you. The rest of you aren't admitting it. So speed is a real issue. Speed is something that we really are focusing a lot here on. And then application availability. And I don't think I need to go too much in this, but the ability to make sure that your application is available quickly, it's always up, that you understand that it's up, how it's running, and you have the ability to push that out wherever is appropriate, be it on-prem, in the cloud, hybrid. Now, some of the things have changed, and everybody talks about this, changes in the threat landscape. I don't know, you've probably seen a million security vendors talk about their threat landscape, and some of them may even have a landscape slide. But the point is that the yesterday's sophisticated attack perpetrated by a nation state is today's, reasonably skilled hacker and tomorrow's script kiddie. So as these things go, they get automated, they get they well understood, they're deployed into new tools. I mean, we've all heard about some of the exposures of some of the NSA tools and so on that were eventually automated, and then you find out they're being used for just about any purpose right now. The point is that sophisticated attacks move into the mainstream very, very quickly. So we have to be able to take a look at and be able to identify these things quickly. Application architectures, movements the virtualization, everybody understands that. We're there, we're well into that. But containers are a big thing. But just recently, I heard about, I was talking to a partner, and they were saying one of their customers is debating whether they're going to actually go into containers or whether they're just going to skip containers completely and go straight to services. So let's go straight to serverless. And they were, that becomes a very interesting situation. I think they're probably a little ahead of themselves, but you get the idea here. And it's not even just the fact that we've got these new things coming in. The new things are coming in faster and faster and faster. So how do we stay ahead of that? Lastly, changes to infrastructure. Now we talked, and I think you guys have probably full to here with HCI and everything else and hybrid cloud and the whole bit there. But the point is it's here. Everybody's adopting it right now, and we have to be able to accommodate it. So I came into this field a couple of years ago from the security side. As a security practitioner, and I was working in security and network security and these kinds of things, and somebody encouraged me to come work for VMware and get into this, and it's like, hey, you can come work with us on the data center virtualization and network virtualization. I'm like, yeah, but what's the big deal in the data center, right? It's just more networks and so on, and and to be honest, when you talk to a lot of security professionals, their focus is more on the outside, right, on the campus, so on. This is their view of the data center. We got racks, we got networks, routers, switches. Maybe we've got a big firewall on the edge of the data center, big nice piece of hardware. Maybe we've got some on the top of the racks because, hey, I'm gonna do some segmentation, isolation of the data center. That's a good idea, right? And well, I know there's some virtualization stuff in there, but not really sure what happens there. But then we say, okay, and on those virtual servers and so on, we've got applications and so on. But what's the desktops? We got desktops in your data center? What's going on here? No, the desktops are outside. That's what I've got all my rules over here. So it's, oh no, you got lots of desktops. So this becomes a bit of a surprise here. And it's like, and VMs that are everywhere, right? And so I'm trying to, as a security professional, it's like, okay, how do I put all these rules out there? You start to get an idea of why it's going to take them 6 weeks to get those firewalls rules into there, right? And then we do this to them, right? And they're like, what the hell? This workload just moved. It's like, what's wrong with you people? And so they come back to us and they say, you know what? This is how we should do it. This is going to make our life simpler. I'm going to say, this rack is now, well, this type of application, and this rack is going to be these applications because this is how my firewalls are set up, this is how my rules are set up, and that's going to make everything better. You'll be able to be faster. And of course, as we all know, that breaks the value prop of half of VMware's products. So what do your application owners end up doing? Well, they just go to the cloud, right? Because now they've got their one-click access to whatever they want. So this is kind of the situation that we're faced with. So looking at this, we talk a lot internally and to you guys and so on. And these is what we look at and feel are the requirements for a secure software-defined data center. The first thing we need is visibility. And this is true pretty much no matter where they're talking in the data center, out of the data center, in the cloud. It doesn't matter. The first thing you want is visibility, because you can't apply policy, you can't protect things that you can't see. The next thing, once we've got the visibility, we want to apply the control, right? So now that we know where things are, we know what they're doing, we can start putting the controls on there. And then on top of that, we can only supply so much control. We want to be able to provide an extensible security infrastructure, because VMware is not going to solve all of your security problems alone. And then working across that, a common policy. So we don't want to have 47 different consoles, so that every different partner at VMware is going to have this. And on top of it, and then finally, the ability to manage that, the life cycle, the deployment, the management, the update, the decommissioning, and so on. We don't want a situation where you've got 400,000 firewall rules in your firewall, and you don't know which ones you can remove anymore. So first step, gain visibility. So right now, So we understand where we, take a look at our data center, we understand, what we have in there. Next, once we have some visibility, we're going to start looking at some granular controls. So instead of allowing all of this east-west communication, we identify who needs to communicate with whom and where. And the last thing we're going to do here is insert our best-of-breed services. And this is the part that we're going to be talking about here. So with NSX, we provide all of this. Now, it probably doesn't come as a surprise to you, right? This is our product. And so, but we do meet all of these requirements here. We're going to give you visibility in the data center, on the entire data center with products like vRealize Network Insight, down into the application with other tools that we have, part of NSX, like Application Rule Manager, and then all the way down into the hosts and the applications with Endpoint Monitor. Give you control with our context-driven microsegmentation. And I think you're all familiar, most of you are familiar with distributed firewall and the concept of microsegmentation. This is really the basis for all of the things that we're going to be talking about. And the last thing is our best-of-breed partner integration. And I'm going to go through this very, very quickly for there's a few people that, just a bit of a refresher on how NSX works here. So much in the same way that we virtualized network and storage compute with vSphere, what we've done with NSX is we've virtualized these standard networking components. We've got your routing, switching, firewall, load balancing, all available in the hypervisor running at line rate speeds. And then we take this, replicate it across all of your hosts, and what do we end up with? We end up basically providing a virtual network layer across your entire data center. All of these things working together, the same way that vSphere gives you the appearance of having a large set of compute that you can allocate as you like, we can do the same thing here with NSX. So we end up going from a stack to a deployment that looks something more like this. So when you start designing your networks like this, they start to look a little bit more like what you drew on the whiteboard when you were trying to design what you want it to look like, and less like the spaghetti diagrams that we typically associate with networking. So we're going to talk about extensibility now, but I am going to pass it on to Vinay because he's going to take us through the network side of the extensibility equation.
Thanks, Rod. So on NSX, as Rod mentioned, is a platform to insert best-of-the-breed services to apply security posture. Now, NSX as a platform provides NOT-bound APIs, and those are leveraged today by some of our partners to address some of these use cases like security policy management and identity and access management. We are not going to talk about these integrations today. What we are going to talk about today is a way to insert best-of-the-breed services at guest or network level. When I mean guest, it's the workload or the application, and then at the network level. So here we insert or integrate with best-of-the-breed partners who can now be, just like distributed firewalls, you can now apply these advanced security services distributed across a large cluster that Rod was talking about, hundreds of these hosts. You can apply and insert best-of-the-breed services there. So the first insertion point is network introspection. I'll talk about network introspection, what it means, what's the architecture, what's the packet flow. And Rod will cover the guest introspection part later. Network introspection basically is inspecting at the network layer as the traffic leaves the workload. And then based on the policy, you insert best-of-the-breed services, advanced security services. Guest introspection is looking inside what's happening in the guest or workloads and then take some actions or redirect some of those to partner services, for example, antivirus, anti-DLP, vulnerability management use cases. So what we have done is these integrations are through SDKs. They're not through APIs. So what happens is partners take our SDK, integrate, and they will be able to integrate with NSX, and we'll be able to insert those services through the SDK. So that's the key. And the key here is both this network introspection and guest introspection, including the partner integration, are tied through a common policy. Since NSX is a platform, it has a rich set of context it can share, and we can define a central policy to apply these advanced services. Now, what we do is once partner integrates with NSX, we have a certification process. That means we take the partner integration, put it through a testing process, certify, and then it would show up in what we call as VMware compatibility guide. So if you go take a look at network and security, VMware compatibility guide, you would see a list of partners in that compatibility guide. So every time we onboard a new partner, we share the SDK, partner takes on that SDK, integrates with NSX, they go through the certification process, and it shows up in the VCG. So if you see this logo, that means they have integrated formally and certified with NSX. Now, what's the process for integrating a service and inserting a service, especially network or guest introspection? Some of the prereqs are all the components that are needed, especially the management domain, right? So you need vCenter, obviously, and you'll have ESXi hosts, you have NSX management components, you have partner management console. This could be if you picked next-gen firewall, then you would have a partner management console installed. And then partner services, especially like next-gen firewall, IDS, IPS, anti-malware, agentless AV, you need those OVAs. And then if you have automation, obviously you'll have tools like vCloud Automation. So the next step is onboarding the service. So once partner is certified, registered, integrated, now how do you get that service onto NSX? So there is a registration process. So you go to once you have a partner who has been integrated with NSX, you register that service with NSX. So that means NSX now catalogs that service. It shows up in its service definition. So you see partners like next-gen firewall, IDS, IPS show up in this catalog. Now NSX admin has a way to deploy this service and consume it, right? So NSX would help in deploying this, not just on one host, if you have 100 hosts, across all these hosts automatically. Once it is deployed, the service is deployed, it's ready to be consumed. How do you consume? Now, service consumption is through the policy framework we touched upon. So you create these abstracted constructs called security groups. You create a grouping based on attributes like all my VMs which are running Windows OSs, or all my VMs that are plugged into port group A. So we have a good way of attribute definitions that starts with just IP sets or based on OSs. You can group these objects. Once you group these objects, you can tie a policy saying web group is talking to DB group. I want to apply a policy. What that policy could be, I want DFW or distributed firewall. Then I want to apply traffic redirection to the partner service. So now you define that policy. Once the policy is defined, then the traffic based on the policy match would be redirected to the partner service. Now, once that is done, you now have to monitor it continuously. So NSX provides way to monitor partner services, alerts. You can decommission, you can remediate, take actions as you're upgrading the ESXi host. For example, let's say you want to move the workloads that are running on a specific host onto a different host without impacting the flows, right? So NSX would allow you to move those workloads before you upgrade your partner services or NSX itself. I'll go through under the hood how exactly things happen when you want to insert network services, especially network introspection. So you have your NSX manager, you have vSphere, you have a host which is ESXi. So vCenter or vCenter manager talks to ESXi over vSphere API to a bunch of processes that are running on each of the ESXi. NSX manager talks to vCenter via vSphere APIs. And when you prep the host for NSX, NSX Manager would install some of the components that are needed for service insertion and firewall. This is the control plane, a part of the service insertion, VSFWD. And this is the data plan that is the kernel module. It is packaged as a WIB. So these are the critical pieces for the security. And this is on every host these WIBs are installed. And you're looking at one host here, but when you prep a cluster which has 64 hosts, all these hosts would have these components. And then once you spin up the VMs are connected to VDS. So now you still haven't integrated the partner. So if, let's say, traffic goes from these VMs, it would just be switched regularly. Now what happens once you register a partner service? NSX Manager now creates a callback to vSphere and deploys the partner's OVA or virtual appliance. Now, this is done through the infrastructure that vSphere provides. And then it is plumbed to talk to the data plane of the NSX. Now, keep in mind, this is the channel, what we call VMCI. It is not connected to VDS. It's a proprietary channel. This is through the SDK, as I mentioned. Once partner integrates, they have access to these, and they get plumbed via VMCI. Now, service is deployed. Now, how do you consume? Once you create a policy, what happens behind the scenes is NSX Manager on that ESXi host, based on the policy that is defined, it creates or plumbs the vNICs of each VM into the data plane of NSX, which is VSIP. Now we have slots. Think of these as slots. Slot 2, as the traffic leaves or enters the VM, slot 2 is slot 0 to slot 2 are proprietary reserved for NSX, and slot 4 to 11 are reserved for partners to take advantage of. So slot 4 could be partner A, slot 5 could be a partner B, other service. So you can redirect the traffic. Now let's see how the packet flows. If VM sends the packet, based on the policy, let's say there is a DFW policy that is defined, traffic hits slot 2, DFW policy gets applied, then moves to slot 4. Now there is a policy to redirect the traffic. Now, the traffic goes through the VSP data plane and then goes through the channel, VMCI channel, to the partner appliance. All this is happening within the ESXi host, right? Before even traffic leaves on the wire. So based on the policy, the traffic entered this partner appliance applied the policy, and then traffic leaves the wire. So this is the architecture of network introspection or service insertion at the network level. Rod will talk about the guest introspections. Any questions on this? Okay. So some of the design patterns, how customers are leveraging this network introspection. So let's say customers deployed NSX for microsegmentation only, so you would obviously have segmented based on VLANs, and then you apply DFW policy, and then use our network introspection to redirect traffic to partner service. Because it's a distributed framework, you can apply this traffic redirection at every host. So here it is microsegmentation on VLAN-based isolation with service insertion. This is one of the common design patterns we have seen how customers deploy service insertion or network introspection. The other pattern is customers want to virtualize their network, so they use NSX to virtualize the network. They're now building overlays. Overlays are used for, again, isolation at the layer 2, layer 3 level. And then they can microsegment at the VM level or the workload level using DFW or distributed firewall, and then insert the traffic using network introspection. So this is the second design pattern we are seeing. I'll go through some of the use cases for service insertion, and I'll go deep on a couple of use cases. So we have seen common use cases for network introspection are customers want to apply advanced security services for high-risk applications. So let's say you have a 3-tier applications, you have deployed it, and you have deployed it on a bunch of hosts, right? You don't know where they are located, but you know this is an app tier, web tier, and the database tier, and you want to insert services to those. And I want to insert only to these high-risk application. The second use case is multi-tenancy. So you have your data center, it's a multi-tenant data center, you have a set of workloads or applications or compute nodes dedicated for tenant A, tenant B. You want to apply these advanced services for these multi-tenant environment. You don't want to spin up an individual virtual appliance for each of the tenants. You want to share a specific service VM that was deployed across multiple tenants. So that's the second use case. The third is DMZ Anywhere, where you're collapsing your DMZ and to a common compute pool. I believe if you have gone to one of those DMZ Anywhere sessions, you would have seen how DMZ is morphing itself from dedicated infrastructure to using a pool of infrastructure for all the DMZ applications. How can we apply network introspection or advanced services to these use cases? And the fourth one is remote office, branch office. We see customers now have tried to consolidate their remote office infrastructure onto a commodity or common platform, and they want to apply security to those workloads as well. So there they want to insert these advanced services as the traffic leaves those remote locations out to either the data center or to the public cloud. And the last is the VDI use case, where you want to apply advanced or UTM kind of security. So I'll walk through one of the use case here, which is how do we apply network introspection to an advanced security, to a high-risk application. So first, the customer here created these 4 tiers of application. And the way they define the tiers is they have logically isolated based on segments. Let's say it's VLAN 10 or VXLAN, whatever. And then each of them are IP segments. They're connected to a common router. So they have isolated the tiers. And they have a bunch of VMs, which are like web server, app server, DB server. Now, using NSX, as I mentioned, you can group these objects, which are workloads, based on certain attributes. So customer would create a group called, let's say, Tier 1 application that defines all the VMs that are connected to logical port group 10, which is VLAN 10. The other aspect is, for every workload that is spun up, you can tag with the capability of grouping them based on certain tags, and partner also leverage these tags when you want to apply for, like, say, IDS, IPS, or anti-malware. When they see something on a certain flow, they can tag those VMs as infected, and they can take action based on that. So you can use those tags to group these workloads. So here, all web server groups are tagged, let's say, red, and all app servers are tagged blue, and DB servers are tagged green. Now, the requirement here was, I want to apply advanced services to Tier 1 confidential workloads. Any traffic coming in and going out of these Tier 1 apps, I want to apply or insert advanced services. So if you look at the policy, because you have grouped these workloads into a security group and applied it to a port group, now you can create a policy saying any traffic coming in, going to this security group, which is defined as Tier 1 applied to port group 10, you can redirect the traffic to a partner service. And the next requirement was all the traffic, web traffic, no matter whether they're Tier 1, Tier 2, Tier 3, Tier 4, I want to insert advanced services. Since you have grouped all the web servers as red, now you can create a policy just like this. Source from anywhere, traffic going to this web server group. Web server group is defined as tags, all the VMs with tags red are web servers. And then since this is applied at the VNIC of every workload, what happens is the traffic gets redirected to a partner, as I talked through the architecture earlier. The next use case is multi-tenancy. And one of our partners, Palo Alto Networks and NSX, collaborated together to support this use case. Here, the requirement is, if you see there are two tenants, tenant 1, tenant 2. Tenant 1 has a bunch of applications defined or grouped based on certain security constructs like all web workloads or HR workloads, and then finance. All these are for tenant 1. And then you have a same grouping for tenant 2. But they are all on common infrastructure. Remember, it's the same 64 host cluster that you're sharing these two tenants to run these application workloads. Now, NSX has a construct called a service profile, which is basically a way to associate a configuration template to a policy. For example, partner has, in this case, Palo Alto Networks, they can isolate or define a tenant as a zone. And then you can create a policy for zone A or tenant 1. Then we can apply that profile, that configuration or template, and map it to a service profile. And when we create a policy, we can associate, if the traffic matches this flow, please associate this with this profile. And we notify partner service VM that this traffic is for profile A, so that when they see the packets or flows, they apply specific policy to that flow. So now what this renders to is, now as you see here, there are 3 profiles here, tenant 1, tenant 2. That means when a partner registers with NSX, they said, I have 3 templates, configuration templates. And each template is mapped to a configuration for a specific tenant. Now, how do we associate that profile to a flow when we define a policy? So here, we are creating a policy, and if you see, this is the profile where we are associating. So source could be any, destination could be a port group. For example, let's say I want to apply to all HR group web applications as the source, and destination could be any, but I want to apply this profile. So here, I can pick this profile and create a policy. And once we do that, as you saw in the architecture, once you create this policy, what happens behind the scenes is NSX Manager would talk to every host and pushes this policy, creates those redirect rules on the hypervisor in the data plane to match these flows. And when they match the flows, they redirect the traffic, but they also tell partner which profile to apply this flow for, so that the partner can now apply that specific configuration profile. So here, if you see, there are 2 same profile applied to 2 groups here. This is tenant A, finance group, HR group are applied with this tenant policy. So all applications that map to these security groups, we have applied this profile, this configuration. So coming to the performance, what is new? NetX up until now, as I showed you in the architecture, this was single-threaded. That means you had only one channel to send traffic to the partner. So that means this was the limitation. Whatever we could do with this was what the limitation was in terms of performance. Now, with release 6.3.2, we created multiple channels. So now, partner services can take advantage of this and have more channels to get traffic and process the packets or flows. Not only this, we also support multi-threading. So if partner service is single process but multi-threaded, same architecture fits well. And we support up to 16 channels. And partner would need a new SDK. So right now, some of our partners are taking this SDK, and they're working on enhancing their service to take advantage of this and get a better performance. So this was the network introspection part of NSX as a platform. Rod will cover the guest introspection part.
Sure. Great. Thank you, Vinay. You want to take any questions right now before we move on?
Sure.
To the next?
If there are any questions.
Sorry,
Yes.
It's not, is that still vCenter?
Yes, it's vCenter UI. If you go to NSX, Service Composer, those were the snippets from the Service Composer. Yeah.
How much of a performance uptake do you see doing multi-threaded?
Can you repeat the question?
The question was how much of a performance improvement we have seen with going multi-threaded. So what we do is when we have this, this framework open, we have our own service VM. It's like a test VM. We test to see how many packets we can do. We today have seen up to 900,000 packets per second, which gives up to like line rate 7-8 gig, depending upon what knobs you turn on, TSO, LRO. If partner supports that, then you can go much bigger than that. Especially between the VMs within the same host, if you turn on TSO and LRO, you can stream 32K TCP stream segments, and if partner supports that, you get much better performance. So it's up, this framework allows us to take advantage of that. Now, depending upon how partners' implementation is in terms of how they handle the flows and packets, performance would vary, right? So that would show up in coming months as partners integrate. They would have their performance specs laid out on their data sheets.
There's no baseline number that was just like, we saw a 10% increase, 20% increase.
Oh, we have seen 5x the performance improvement because it was single-threaded. Right. Now you have 16 channels. It's up to partners to take advantage of it and suck up packets.
Any questions? Okay. Oh, one in the back.
Yes, as I mentioned, there were slots 4 to 11.
Repeat the question.
The question was, if I have multiple partners and I want to insert those, can I define it in a priority order? As I talked through the architecture, there were slots 4 to 11. So you can insert those partner services based on how you want to have them inserted on slot 4, 5, 6. So you have a priority order there. Come again? Yes, service policy, service composer.
Sure,
Go
take one more.
So that means the service appliance has to be installed every host, right?
Exactly.
And does this mean that since we're only redirecting locally, that means there should be session-based application across all of these service appliances? Because, the request can go from one service appliance and the reply can go from another service appliance?
If it is within the host, if you see the flow would go through a set of appliances there and leaves the ESXi host, when it enters the other side, if you have a policy to redirect the traffic to the service, again, it depends on how you define the policy, in or out. You can only apply services on one, let's say in here, one host. There were 3 VMs. When they were talking to a VM on the second host, if your policy says traffic from VM A, which is on host A, I want to redirect to service 1, service 2, service 3, then it will only apply that policy as it leaves VM 1 because the source of the policy is VM A, right? You don't apply it on the second host.
What about the reply?
The policy won't apply because the traffic is applied. Key here is the redirect is happening at the VNIC level, right?
You mentioned earlier some of the reserved slot numbers for VMware services versus third parties. Does that indicate there's a limit of the number of services that can get plugged in because there's a limited number of those slot identifiers?
Yeah, so right now 4 to 11, so you have 8 slots. So you can apply 8 services. We have not seen any customers who have gone beyond 1 or 2. Pretty much, yeah.
What dictates that regard of those slots? Is that an open architecture? Can anything have access, or is there an API or a closed API that makes that work?
So as I mentioned, if partner has to integrate with NSX, we give the SDK.
Yep. Yeah, the question was basically, is it open? Can anybody insert a service and so on? And the answer is both for the network service insertion as well as I'm cleverly segueing into the guest inspection here. Both of them are programs, so they're sort of programmatized, and we have, much like the Technology Alliance Partner Program, we have an SDDC Partner Program above that. And essentially, they get access to the SDK, and then we have a certification process and all of that too. Because essentially, I mean, one of the things, as you notice, these are getting into the hypervisor, and we don't want to be taking support calls because, Bob's Security RS, is running their software in our hypervisor. So, yeah.
As far as that slot number that gets assigned, is that just based on the deployment of that service, or based on the type of service the third party is providing? Are they given a slot like distributed firewalls take 5 or whatever the case?
Yeah, so distributed firewall, if you saw the architecture, 0 to 2 are all NSX provided services. Slot 2 is DFW or distributed firewall. Anything after that, slot 4 to 11 are for partner services.
Like Palo Alto.
Yeah.
So you use
4.
Now, is it using 4 always, and is it going to use 5 because of
Yeah.
the partnership with you guys?
The number is arbitrary. Based on the order you want to apply it, it will just, you put it in there.
It's going to take 4. The next
4, yeah.
Yeah.
You can change that priority order based on your requirement, but
Right.
Well, I was just curious, if you had it based off of a particular type of service, like firewalling services, whether it be
Yeah.
or another.
It's just a slot. Yep, exactly. So I'm going to move forward. Actually, I have a question now because, well, you have a question. We'll have to be quick. So the question is, can we define the traffic redirection at the port level?
port level, TCP, UDP port level, or port at the logical port level? Yes, you can. You can apply the same constructs that you apply for distributed firewalls. You can apply the redirect policy. I mean, Rod will cover at the end the whole policy framework, which walks through the guest introspection, DFW network introspection, how we can define that policy in one go using Service Composer.
Right. So I have a question for you guys. How many of you are responsible for endpoint security? Okay. How many of you know the person who's responsible for endpoint security? Okay. How many of you didn't put up your hand yet? Okay, everybody's woken up now. Okay. So for those of you who know the person who is responsible for endpoint security, please let them know about what you're about to see, because one of the things about NSX is it has a value for a lot of different groups of people. Networking, network security, endpoint security, VI admin, application developers, and so on. So we really encourage you to talk about these different features with the other folks that are in your IT organization, because it can provide some really interesting conversations once you open up those lines of communication. And for those at the end that don't know who does endpoint security, find out. It can actually be very interesting. There's some very interesting things that can be done once you start to look at what can be done on the endpoint versus what can be done on the network. And you may find that something, as a network security person, that the endpoint administrator actually has a bunch of information on the endpoint that you could leverage with NSX to help define your policies. And endpoint person may be surprised to find out that you can solve some of their problems on the network. So it's worthwhile taking a look at this. So talking about guest introspection, one of the things that we've always struggled with, and this is, I don't know if any of you guys have seen the app defense or seen Tom Korn talk. He says this much more eloquently than I could ever aspire to. But whenever we're talking about applying security, we often separate it out into where we're going to actually apply that security. And typically, we have 2 different places we can do it. We can do it on the network, or we can do it in the guest. And there's advantages to both of these. You do it on the network, you're completely isolated from that guest. That guest gets compromised, no problem. I'm just going to block them out on the network. If I'm in the guest, however, I get a ton of context that the network inspection can only dream about, right? But now I'm also exposed to attack within there. So what we have with VMware running in the hypervisor, we actually have the best of both worlds. We have the visibility into the guest through a number of our tools and so on, and the fact that we're actually running those guests, but we also have the isolation from the guest because we're sitting on the hypervisor. So this gives us what we used to call this the Goldilocks zone, which was actually the name of the App Defense before it became App Defense. But the point is that this is where we're applying these services. This is where guest introspection goes. This is where the network insertion goes, and it really is something that is really unique in the marketplace, which is why we're so excited about this and offering it and always adding more partners to get in there. But when we talk about visibility into the guest, we have a real variety of things that we can look at here. We can look into the users. We can see file writes, file reads, what processes are running. We can look at the Hive where the various different Windows storage and so on. We can even look at network connections and so on. So we have a huge amount of data that we can leverage inside of there. And this is the kind of data that our guest introspection partners, such as our AV vendors, leverage to provide their solutions. So let me talk a little bit about how this is built. And this isn't quite as detailed as Vinay's slide, so I'll bear with me if it doesn't have as many moving parts. But first of all, when we talk about the architecture here, so on the right-hand side, we have our ESXi, we have our hypervisor, and we have our managers. We got NSX manager, and we got vCenter manager. On top of that, we have our guest VMs with their applications, and we also have VM tools that are installed on there. Now, when we're running guest introspection, or for that matter, network introspection, we also have a partner security VM. Now, I realized after I did this, it's like, wow, that's using up 90% of the resources on my hypervisor there. Look at that. But no, actually, it's the same size as the others. I needed to make it big for the rest of the build. So, but the point is that so they've got their own VM, and they've got their security application that runs inside of that VM, and we handle, and I'll show you a little bit more later, but we handle the deployment and the management and basically the plumbing that in on the hypervisors, on the hosts, as needed. So all of that happens automatically. Inside of VM tools, there's a couple of drivers called guest introspection drivers. And I don't know if you guys have ever seen that when you've looked at VM tools. If you click the little plus on there and you see what's loading in there, you'll see them. And those are the things that we leverage to provide these guest introspection services. Now, just to be clear, network inspection, the NetX, network insertion that Vinay has, is not leveraged through VM tools. That's actually completely outside of the guest and implemented completely inside the hypervisor at the VNet level. The partner takes our guest introspection library. So this is the SDK that Vinay was alluding to, and they build this into their security VM. And what that SDK does is it gives them access into the processes, into the files, into the system events, into some of the socket calls and so on that occur on the VM. So anytime any of these system calls occur, the partner VM gets a notification, and they can decide based on the antivirus policy, for example, whether or not they want to deal with that. So they get notification of all these things, but and this is actually kind of important, the policy in NSX defines whether or not you install antivirus, right? The policy that the partner handles is what kind of antivirus you do, because we're not experts in intrusion prevention systems or in anti-malware or in vulnerability assessment and so on. So the partners are. So they have control over that policy. So, and then on the northbound side, the partner management console, which is basically communicating directly with their own security virtual machine on there, also communicates with NSX Manager. And this is very important because that means that we are now coordinating policies. So when we create the security groups, when we create our tags and so on, that can be done, that's done automatically by the partners. For example, Vinay was talking a little bit about tagging. For example, we discovered that a VM has been compromised, and we're going to go ahead, and the partner will go ahead and set a tag that VM's been compromised. So when we talk about how this actually gets deployed, and this is more like a movie of how it gets deployed versus the screenshots that you were seeing from Vinay, but it gives you an idea of what happens here. And the assumption in this example here is that we've set up on the cluster, that we've installed, the service has been registered, and the security VM has been uploaded to that cluster. But that's it, right? Everything else happens. So in this case, we've got a number of VMs that have different security policies applied to them, and there's a number of security VMs running on those as well. So in this case, we add a new host to the cluster, right? So this can happen through automation. It could happen manually. It doesn't matter, but we get another host on the cluster. Next thing that happens is those security VMs, those are automatically instantiated on the new host. You don't have to do anything, right? It's like, because the cluster supports this kind of capability, we're going to make sure that that capability is available so that when any VMs come there, it's ready. And so, for example, when we instantiate a new VM on that, automatically gets the appropriate policy applied. And once again, this is all automatic, because based on what the VM is, what tags are applied, maybe its name, it doesn't matter. There's a number of different attributes you can use to define what that VM is. But based on those attributes and the security group memberships and the policies that you've specified for those security groups, that will automatically be applied there. And the same thing's true if we have a vMotion occur. So as soon as that moves over, we'll make sure that also gets the same policy. So the important part here is that the security policy and the inspection and the capabilities and so on, those are tied to the VM. They're tied to what the VM is and all of the attributes of that VM. They're not tied to where it is, or its IP address, or what host it's on. They're tied to what it is specifically. So let's take a quick look at how this works when we're talking about I'm going to talk about the agentless antivirus use case. That's probably the most common one here. So in this case, we've defined a group here, and the membership criteria that we've defined is that it says virus found, right? So, and that's pretty much all we're going to say. And I think in this case we called it, what do we call it? Antivirus. Okay, similar idea. But in this case, we find a virus on that host. The partner system defines the partner security VM, finds the virus on there, and we've set up, it automatically will set the tag for a virus on there, and then because of that tag, that VM now, it belongs to a new security group based on that tag, and the policy for that security group is that it's going to be quarantined. So just by the simple fact of finding the virus on there and setting a tag, it automatically gets quarantined. Typical use cases that we see for this, by far the biggest use case here is for VDI desktops. And one of the major reasons here is if you imagine you've got VDI hosts with hundreds of desktops on there, managing your antivirus agents one by one, it becomes a very, very difficult task. And same goes for updating those signatures, because potentially they'll have to be updated while the host is running. They could be running for days. That becomes a real problem, and it seriously improves the consolidation ratios as well. So if you guys are in contact with your VDI admins, this is something really worth bringing up. We have customers that have literally hundreds of thousands of them on there. Doing Windows Server protection, same thing. Basically, I'm going to actually accelerate a little bit here, but the point is that anywhere you would be doing any kind of anti-malware or antivirus, including Linux boxes in this case, that's definitely a really great opportunity for those kinds of deployments. Any of you using VCNS right now? Okay, it's time to upgrade. Yeah. I think, yep. Yeah, I extended the the life once, you know, you can only do that so many times. But yeah, there's a lot of reasons to upgrade though. Besides the fact that we don't actually support it anymore, there's a lot of benefit to moving to NSX here. And I'm not going to go through all of these things individually here, but you know, I encourage you to definitely talk to your partners, talk to your VMware rep, and about making that happen there. So taking a look, I want to close it out and show you how this looks when it comes to a policy. This is Vinay kind of talked about here. This is what a policy looks like when you want to add any one of these insertion areas here. So the first thing we do is we set up a policy. We're going to set up a new policy here, and we're going to say what kind of, say I want to put some guest introspection, and it just walks you through here. So it's like, hey, I've got an endpoint. I want to do some antivirus on it or something. I just click it. Okay, let's move on. Next thing, we're going to have some firewall rules that are applied to that. Once again, there can be a selection of those. We apply those. These are DFW rules. And it continues to walk through into what kind of additional services do you want to apply on the network. So all of this, it's all attached completely, you know, it's set up to be very, very obvious, very intuitive, very easy to be able to add all these services. And then this is now attached to any VM that has those tags on there too. So this only needs to be defined once. Lots and lots of partners. So I suspect you'd probably see, my guess is looking at especially the second from the top row there, we do partner with all the best of breed security vendors, and that list is always growing. We have a number of other vendors that we're talking to right now. You know, and you know, once again, if you've got a partner you don't see on there that you want, please let us know, and we'll work with them to get them into the program. So wrapping it up, you know, we've talked here about the requirements here for a secure SCDC. They started out with visibility, control, and extensibility, right? And I think we made the case, hopefully, for extensibility in your environment, and layering on top of that the common policy, as well as the lifecycle management. And hopefully this will get you encouraged to try this out, because you know, it's really a much better way to go after this than your physical firewalls or putting them in the top of rack. This is a good one to take a picture of because this is basically, if you want to get some more information on this, I mean, half these sessions have already happened, obviously, but all of these things are available on VMworld.com. So if you want to get additional information on service insertion, maybe a deeper dive, or some more information on automation and so on, these sessions will definitely help. Oh, I'm sorry. It's going the wrong way.
It's done.
Oh, sorry, but...
Thank you.
Okay.
We'll take questions for 5 more minutes.
Yes, it is. Yep.
Thank you.
Yep. Any more questions, we can take them out in the back there. I think we've been... Yep. Thank you.